Hello, hi, welcome back. So now I'm gonna show you how to use Euler's method. Okay, so what is Euler method? Euler method is just an approximation method for you to find the approximation value for the solution at equally spaced. Example, you have x0, x1, x2 and so on. Okay, so here you are given the slope at x0, y0, which is written as y prime equal to f x0, y0. Okay, this is actually given in the questions. Yeah, so what you are trying to find is actually you are trying to approximate value of the solution when your x equal to 1. What is the value of y1? Okay, so the value of y1 you will obtain by having this equation. What is the value of y2 when x equal to x2? So you are going to obtain the value of y2 using this equation. Same thing goes to y3 and until yk plus 1. So that is why we have the general formula for Euler method as written here. So you can get the value of yk plus 1 equal to yk, the previous k, plus h times f xk yk. So where do you get this f xk yk? You got it from the slope that given to you. Okay, remember the ODE? The dy dx equal to the function here. Okay, you just embed it there. So this is the general formula for Euler's method. Alright. So let's go to the equation. Let's go to the example that we have in here. So this one, you can get the details of this example from the lecture notes. Alright. So here, use Euler methods to numerically integrate dy dx equal to x cubed minus 2x plus 3 from x equal to 0 to x equal to 3 with step size of h equal to 0.5. And you are given the initial condition at x equal to 0 is y equal to 1. So what is this all about? You are actually trying to find out what is the value of y. Okay, I'm going to put it here. You have 0. Remember that you have x not equal to 0. And the step size is 0.5. So you have the next one is 0 plus 0.5, which is 0.5 here. x2 is 0.5 plus 0.5, the step size. So this is 1.0. x3 is plus it 1.5. x4 is 2.0, x5 is 2.5, and until x6 equal to 3.0 because it is from x0 to x equal to 3. So you have all the x here, and your job now is trying to find out the value of y0, y1, y2, y3, I hope you can see this, y4, y5 and y6. You are trying to find this value using this formula here. Okay, right, so how to do this? Okay. I put it here. So you recall Euler's method. So this is the Euler's method. This is the formula. Yk plus 1 equal to yk, the previous one, plus hf xk yk. And remember that this is given in your equations. This is what you are trying to integrate. Okay. So this is from the questions. And this can be simplified to, this is actually y prime. So that's why we simplify it to y prime equal to x3 minus 2x plus 3. And this one, I recall it back. The step size that we are going to use is h equal to 0.5 with initial value. Remember the initial value that were given before? It is y0 equal to 1. Or you can simply say when x is equal to 0, y is equal to 1. Okay, so you are going to solve this iteratively, and remember that you have this. So this is k naught, this is k1, k2, k3, k4, k5, k6, meaning that you have 6 iterations. You actually have 6 iterations to solve these questions. Okay, let's go to the first iteration. First iteration, we put it here as k equal to 0. Remember, k equal to 0, you need to find out what is the xk. So since k is 0, so our x is x0 or x0 equal to 0. And yk, or the k here is 0 here, so yk is y0 this time around is equal to 1. And please remember that for k equal to 0, this one is actually, you got it from initial value. This is where you got it, from the initial value. Look, you have x0 equal to 0 and you have y0 equal to 1. Alright, now you move on to the next iteration. So you have k equal to 1. So k equal to 1, you need to find again xk. So our k now is x1. So x1 is equal to, because you need to increase the value of the x using the step size. So that's why you need to put it as the previous one plus the step size. So x0 plus h. So x0 is from here. So 0 here plus 0.5, you got 0.5 in here. Next is you find the yk. And because our k here is 1, so we are trying to find y1. Okay, so y1 is equal to, using the formula here, this is the formula. Remember the formula that I show you here. Okay, this is the one that we are going to use it iteratively. So you have y0 plus h function x0 y0. Okay, so this one here, y0 is equivalent to 1. Remember, y0 equal to 1 here. Okay, and then plus h. So h here is the step size. So that's why we put it here, step size here. So you may be asking me, what about this value? Okay, so remember that I show you before this. That the slope at x0, y0 is this one. Y prime, we make it y prime equal to f x0, y0. Okay, so here, this thing, you plug into this one. So where to get that? That is from the questions, alright? So again, coming back to here, alright? So f x0, y0, you can get it from y prime equal to f x0, y0. So in this example, alright, in this example, our y prime is equal to x to the power of 3 minus 2x plus 3. So then you are going to put this whole value when x is equal to 0 in here. Okay, so that's why I'm going to show you again. You are trying to find the value of y1. So that is equivalent to the previous value, which is y0. So y0 is 1. Plus h. H is 0.5. And you have this whole part here, which is coming from the equation that you have in here. The only difference is you need to substitute the value of x0 in this equation. So that's why our x, because x0 is 0, that's why we've got like this. And you see here, this is x cubed, so 0 cubed, minus 2x, so minus 2 times 0, plus 3, so you have plus 3. Okay, therefore we've got here as 1 plus 0.5. This whole thing, when you solve it, you've got 3. Therefore, you've got the value of y1, I put it here, y1 is 2.5. Okay, now remember that you need to find out y0, y1, y2, y3, y4, y5, and y6. That one there, I only show you the first iteration that's coming from the initial value, second iteration. Now I'm going to show you the third iteration, which we arrive at k equal to 2. So again, we need to specify our xk. Because k is 2, so we are trying to find x2. And remember, x2, we obtain it from the previous x plus h. So the previous x is x1. So that is actually x1 here coming from here. Remember? Okay, so that's going to be x1 0.5 plus h, which is plus 0.5, the step size. So we have 1.0. Okay, so when x2 is equivalent to 1.0. So what is the value of the y2? So the value of y2, or yk here, because k is 2, so y2 is equivalent to the previous y, which is y1, plus h times with, again, the function here, fx1, y1. Remember that fx1, y1 is coming from this one. Okay, I'm gonna put it here. 1, y, 1. So in this example, again, this is y prime is x3 minus 2x plus 3. So this time around, we need to substitute the value of x1. So the x1 that we've got is 0.5. So you substitute 0.5 in here, 0.5 in here, 0.5 in here. So that is why you've got something like this. Okay, you've got like this. So again, in order for you to get y2, that is equivalent to y1. So y1 is 2.5 plus h. h is 0.5. And this function x1, y1 is coming from the example that we have in here. Okay, take the whole part this. Okay, that's why, and then you substitute the value of 0.5 in here. So that's why when you solve all this, you will obtain 3.5625. Okay, then as I said to you, you need to solve it until x equal to 3, which is actually x, this is k3, k3, k4, k5, and finally k6, which is actually k6 here is xk or x6. So I need you to fill in the blank. Okay, I also supply the answer here. Okay, so you should be able to get x1, x2, x3, x4. This is x0, I guess. 0, 1, 2, 3, 4, 5. X6. This one is very easy. You can just get it by adding the step size. The job is to get y0, y1, y2, y3, y4, y5, and y6. Okay? By using the by using the Euler's method. Alright? Okay, good luck.